Hello everyone. In today's lecture, I like to discuss complex number and quadratic equation. So firstly, I discuss introduction of complex number, and then I'll discuss what is the definition of complex number, and then algebra on complex number, that is addition on complex number, subtraction on complex number, multiplication on complex number, and division of complex number. After that, I'll discuss the power of I. What is the value of I cube? What is the value of I to the power 4? And what is the value of I to the power 200? And so next, I will discuss uh, what is the definition of conjugates, what is the definition of modulus, and how to find the modulus and how to find the conjugate. And next, I'll discuss about argument plane and how we denotate a complex number in argument plane. Okay.
So in earlier classes, we have studied linear equation in one variable and two variables and quadratic equation in one variable. We have seen that x squared plus 1 equal to 0 has no real solution. Has no real solution. Has no real solution. Gives s as x squared plus 1 equal to 0 gives x square equal to x square equal to minus 1. So there exists no real number such that x square equal to minus 1. So we need to extend the real numbers system to larger system so that we can find the solution of the equation x square plus 1 equal to 0. In fact, the main object is to solve the equation ax square plus bx plus c equal to 0 when the discriminant is less than 0. All you know that the solution of the quadratic equation is x equal to minus b plus minus root over b square minus 4ac divided by 2a. Here discriminant is d equal to b square minus 4ac. Now, if d is greater than 0, then we don't have any problem. That is, there is just a real solution. But whenever discriminant is less than 0, we faced problem. We faced problem. So, our motive is to find a solution whenever d is less than 0. Now, I discuss complex number. Complex number. In the quadratic equation x square plus 1 equal to 0, x square equal to what? X square equal to minus 1 and x equal to what? Square root of minus 1. Now we want to find x whose gives square root of minus 1. Now let us denote. Now let us denote. Let us denote I equal to square root of minus 1. I equal to square root of minus 1. Then we have then we have I square equal to what? I square equal to square root of minus 1 square. This gives minus 1. This means this means that I is a solution of the equation. I is a solution of the of the equation. So a number of the form a plus iv, where a and v are real numbers, a and v are real numbers, is defined is defined to be a complex number, to be a complex number, complex number. So a number of the from a plus iv, where a b are real numbers, is defined to be a complex number. For example, for example, 2 plus 3i, 2 plus 3i, and minus 1 plus I root 3, 5 minus 6i. These are the examples of complex number. Are complex number, right? Are complex number. For the complex number, for the complex number, complex number z equal to a plus iv, a is called a is called real part, is called real part, and denoted by what? Denoted by re z. And b is called the imaginary part, and b is called b is called the imaginary part, imaginary part, and and denoted by denoted by im z. For example, if I take, for example, if z equal to 3 plus 2i, then real part of z is what? Real part of z equal to 3, and and imaginary part of z is what? Imaginary part of z is 2. Imaginary part of z is 2. Next concept is when two complex number are equal. When two complex number are equal. Now two complex number, two complex number z1 a plus iv and z2 and z2 c plus id are are equal if a equal to c and b equal to d. This means if the real parts real parts of the complex number are equal and the imaginary part of the complex number are equal. Real part and imaginary part equal, then we said that these two complex number are equal. Okay, let's just understand with one example. If 4x plus I 3x minus y equal to 3 plus I minus 6, where x and y are real numbers, where x and y are real numbers, real numbers, then find the the values of x and y. So in the question, given that if 4x plus I 4x plus I 3x minus y. So this is also from a plus ib. So this is one a complex number, and in right hand side 3 plus I minus 6, and this is also other from a plus ib. This is also another complex number. So these two complex number are equal. When we know that the two complex number are equal if what real part are equal and the imaginary part equal. Okay. So right in solution we have we have okay, so this side, not this. So we have 4x 4x equal to 3 and what 3x minus y 3x minus y equal to minus 6. So here x equal to what 3 by 4, x equal to 3 by 4, and if I substitute x equal to 3 by 4 here, so this gives 3 multiplied with 3 by 4 minus y equal to minus 6. So this equal to 9 by 4 minus y equal to minus 6. If I transport y in right hand side, or if I transport 9 by 4 in right hand side, then what we get y equal to 9 by 4 plus 6. So this equal to what? Y equal to 9 plus 24 divided by 4. So y equal to what? Y equal to 33 divided by 4. 33 divided by 4. Understood? So here I discussed if two complex number are equal, then the real part are equal and the imaginary part is equal. Imaginary part are equal. So here real part is 4x and the first complex number and the second complex number is 3. So we equal the real part. 4x equal to 3. And this one linear equation, and linear equation this gives x equal to 3 by 4, and the next is what imaginary part are equal, so 3x minus y equal to minus 6, and we substitute x equal to 3 by 4 in the second equation. After substituting this I get y equal to 33 by 4. So what is the value of x and y? The value of x is 3 by 4 and the value of y is 33 by 4. Now, I will discuss algebra of complex number. Algebra of complex number. So, firstly, I discuss addition of two complex number. Addition of two complex number. Addition of two complex number. All we know how to add two real numbers, right? Now let's discuss how to add two complex number. Let let Z1 equal to a plus iv, one complex number, and Z2 equal to c plus id, c plus id, another complex number. So here Z1 and Z2 be any two complex number. Then the sum, then the sum define define y Z1 plus Z2, and it's equal to what? A plus C, A plus C plus I, B plus D. So if Z1 and Z2 any two complex number, then the sum defined by Z1 plus Z2 equal to what? Sum of the real parts. Here the real part is what? Real part is A in the first complex number, and in the second complex number real part is C. So we add the real part A plus C, and we add the imaginary part. So B plus D. Now we understand with one example. For example, let let Z1 equal to 5 plus 3i, and Z2 equal to 2 plus 11. So we want to find Z1 plus Z2. Z1 plus Z2 equal to what? So Z1 plus Z2, Z1 plus Z2 is equal to what? Z1 is 5 plus 3i, and Z2 is 2 plus 11i. So 2 plus 11i. Now here 5 and 2 are the real part of complex number. So we add 5 plus 2, and here 3i and 11i. If I take common I, so what I get? 3 plus 11, and this is equal to what? This is equal to 7 plus I and 14. So Z1 plus Z2 is 7 plus 14i. And the addition of complex number satisfies the following properties. Next, I'll discuss some properties that addition of complex number are satisfied. Already we know that the real number is satisfies that closure property, commutative property, and multiplicative identity. There exists a multiplicative identity. There exists an inverse. So let's see, for complex number these properties are satisfied or no. So for the complex number also these properties are satisfied. So the addition of complex number, the addition of complex number, complex number satisfies the following properties. Satisfy the following properties. The first property is closure property. Closure, the closure law. The closure law. Here I take any two complex number. Here I take arbitrary one complex number z1 equal to 5 plus 3i, z1 is 5 plus 3i, and z2 is 2 plus 11i. After that, I'll find the sum z1 plus z2. What I get? After adding these two, I'll get 7 plus 49. 7 plus 49. And this is also what? This is also one complex number, because this is also a plus ib from a plus ib from. So it satisfies the closedness of complex number, that is the sum of two the sum of two complex number is a complex number, is a complex number, complex number. I z1 plus z2 is complex number, is complex, sorry, complex number, complex number. Next, the commutative law for any two complex number. Commutative law of any two complex number. Second property is commutative law, commutative law of any two complex number. Okay. So we will check when commutative, if a plus b, if a plus b equal to b plus a for any complex number, then we said that complex number is commutative in addition. Okay. So let z1 equal to 2 plus 3i and z2 equal to 1 plus 2i. Now we see z1 plus z2 and z1 plus z2. So z1 plus z2 equal to what? 2 plus 3i, 2 plus 3i, and plus 1 plus 2i. Now this can be written as 2 plus 1 and 3i plus 2i. Now if I add this to 2 plus 1, 3, and here 3i plus 2i, this equal to 5i. And this can be written as 5i plus 3 also. So this equal to what? This is nothing but z2 plus z1. z2 plus z1, right? Because z2 plus z1 is what? z2 plus z1 is, z2 is 1 plus 2i, 1 plus 2i plus 2 plus 3i, 2 plus 3i. So this can be written as 2i plus 3i plus 2 plus 1. So this equal to what? This equal to 5i plus 3. 5i plus 3. So z2 plus z1 equal to z1 plus z2. So in addition, complex number is commutative. Next, associative law. Next is associative law. Complex number also satisfies the associative law. Third property is associative law. If I take three complex number, let Z1 is equal to 1 plus 2i and Z2 equal to 2 plus 3i and Z3 equal to and Z3 equal to 3 plus 2i. We know if if it satisfies this property that a plus b plus c equal to a plus b plus c, then complex number is associative. So we'll check this property a plus b plus c equal to a plus b plus c. This holds or not? So firstly we'll check a plus b plus c. If I add first two, that is z1 z1 plus z2. After that, I will add Z3. Z3. So here, Z1 is what? Z1 is 1 plus 2i. 1 plus 2i. And Z2 equal to what? Z2 equal to 2 plus 3i. So 2 plus 3i. And Z3 is what? Z3 is 3 plus 2i. 3 plus 2i. If I add these two complex number, what I get? So 1 plus 2 plus 2i plus 3i and plus 3 plus 2i. So 1 plus 2 equal to what? 1 plus 2 equal to 3 and 2i plus 3i it gives 5i. Now this is one complex number and this is one complex number. So this equal to what? 3 plus 3 plus 5i and plus 2i. So this equal to 3 plus 3 it gives 6 and 5i plus 2i so 7. Now I will check Z1 plus Z2 plus Z3. Z1 plus if firstly I add Z2 and Z3 and after that I will add Z1, then what I will get? So Z1 is what? Z1 is 1 plus 2i. Z1 is 1 plus 2i and plus J2. J2 is what? J2 is 2 plus 3i. 2 plus 3i. 2 plus 3i. And Z3 is what? Z3 is 3 plus 2i. 3 plus 2i. So this equal to 1 plus 2i. If I firstly I add these two complex number, then I will get 2 plus 3 plus 3i plus 2i. So this equal to what? 1 plus 2i plus 2 plus 3. This equal to 5 and 3i plus 2i. This equal to 5. Next, this one complex number and this another complex number. So I add this to complex number 1 plus 5 plus 2i plus 5i. This equal to what? 1 plus 5 is equal to 6 and 2i plus 5i this is equal to 7. So what I get? 6 plus 7i. And here also I get 6 plus 7i. Since Z1 plus Z2 plus Z3 equal to Z1 plus Z2 plus Z3. So complex number is associative. Complex number is associative. Next, the existence of additive identity. Existence of additive identity. Fourth property is the existence of additive identity. existence of additive identity. So in real number, we know that here if I take any real number a, I'll get 0 and a plus 0 equal to a. So in complex number also, we get 0 plus 0i, 0 plus 0i. If I add any complex number with this 0, we denote it as 0. So z plus 0 will get again z. For example, if I take z equal to 2 plus 3i, 2 plus 3i. Now if I add z plus 0, that is 2 plus 3i, 2 plus 3i plus 0, and 0 is what? 2 plus 3i plus 0 plus 0i, and so 2 plus 0 and 3i plus 0i. So 2 plus 0 is 2 and 3i plus 0i is 3i. So z plus 0, again I will get this equal to z, this equal to z. So in complex number, there exists a additive identity. Next is the existence of additive inverse. The existence of additive inverse. Fifth property is the existence of additive inverse. Or you know, in real number, that is, if I take any real number a, then I will get another real number minus a, such that a plus minus a gives 0. See, in complex number, it's happened or no. So if I take, firstly, if I take any complex number, let's arbitrary complex number a plus iv, there exists another complex number z such that minus a plus minus iv, sorry, minus iv. Let this equal to z1 and this is z2. So z1 plus z2, this equal to what? A plus iv and plus minus a, sorry, minus iv, and this equal to what? A plus minus a minus, so this equal to minus, and here plus iv and plus minus minus, so there here minus iv. Now plus a minus a, this gives 0, and plus iv minus iv, this also gives 0. So I into 0. So this also 0. So z1 plus, since z1 plus z2 gives 0, so for any complex number a plus iv, we'll get a complex number minus a plus I minus b. So there exists an additive inverse. Now I'll discuss difference of two complex number. Difference of two complex number. Difference of two complex number. Okay. So all you know how to find the difference of two real numbers. Now I will discuss the difference of two complex numbers. Suppose let z1 equal to a plus iv, one complex number, and z2 equal to c plus id, another complex number. So the difference defined as z1 minus z2, and it's equal to a plus iv plus, sorry, minus J2. So J2 is C plus I. Next, A plus IV plus minus or minus. So minus C and plus minus or minus. So minus ID. And this equal to what? A minus C and plus I B minus D. So difference of two complex number is defined as A minus C plus I B minus D. Let let understand with one example. Let Z1 equal to 5 plus 2y and and Z2 equal to 3 plus 3r. Now we want to find the difference of Z1 and Z2. So here Z1 is 5 plus 2i and Z2 is 3 plus 3i. So Z1 minus Z2 it's equal to what? 5 plus 2i minus 3 plus 3i. And this equal to 5 plus 2i and plus minus are minus 3 and plus minus are minus 3i. And this equal to, and this can be written as 5 minus 3 and then plus 2i and minus 3i. This equal to what? 5 minus 3, it gives 2 and 2i minus 3i, it gives minus I. So Z1 minus Z2 is 2 minus I. Now I discuss multiplication of complex number. Multiplication of complex number. Okay. So let Z1 equal to A plus IV. Let Z1 equal to A plus IV and Z2 equal to C plus ID. C plus ID. And any two complex number, and then the product Z1 and Z2, then the product Z1 Z2 is defined as Z1 Z2 equal to AC minus BD plus IAD plus BC. Okay, let's see how it comes. So here Z1 is what? Z1 is A plus IB and Z2 C plus I. We want to find Z1 and Z2. So Z1 multiplied with Z2, this equal to what? A plus IV multiplied with C plus ID. Well, you know distributive property. Distributive property is what? If A multiplied with B plus C, this equal to once A multiplied with B and plus sign, so plus and A multiplied with C. Here also we use the distributive property. So firstly, A multiplied with C plus ID, C plus ID, once A multiplied with C plus ID and once IB multiplied with C plus ID, C plus ID. Okay. C plus ID. Now again we use the distributive property of multiplication. So here once we multiplied A multiplied with C and once A multiplied with this one. And here also we use the distributive property once IB multiplied with this one and IB multiplied with this one. So if I multiplied with this, so A multiplied with C and if A multiplied with ID, this is equal to what? A multiplied with D. And I multiplied with this, IB multiplied with this one, so I BC and here IB multiplied with ID, so IB multiplied with ID. If I simplify this one, then this equal to AC and this equal to IAD plus IBC and here I multiplied with I, so I square and I square is what? I square, well you know that here I square equal to minus 1. Earlier I defined that I is square root of minus 1. So I square is what? I square is minus 1. So here I will take I square equal to minus 1 and here B and D. So B multiplied with D. Next AC. Now BD can be written B minus D and here if I take common I, then what I get? ID AD plus BC. So J21 multiplied with J2, this gives AC minus BD plus I AD plus BC. Okay, let's understand with one example. Let J1 equal to 2 plus 3I and J2 equal to 1 plus 5I. Now we want to find Z1 and Z2. So Z1 and Z2 is what? 2 plus 3I multiplied with 1 plus 5I. If I compare with the general case A plus IB and C plus ID, what I'll get? A multiplied with C. So 2 multiplied with 1 and plus no, A multiplied with C minus B multiplied with D. So here B is 3 and D is what? D is 5 plus I and A multiplied with D. So here A is 2 and D is 5 plus B multiplied with C. Here B is 3 and C is 1. So 3 multiplied with 1. This gives 2 minus 15, so minus 13 and plus I and this is equal to what? 10 and 3 multiplied with 1, 3, so 13. So minus 30 plus 13. Understood? Okay. So multiplication also satisfies the closeness. See, here I take two complex number Z1 and Z2. I will take arbitrary. You will take here I will take arbitrary. That is Z equal to Z1 is A plus IB and Z2 is C plus IB. So after multiplying that, I will get AC minus BD and plus I AD plus BC. So again, it is in the form that is A plus IB. So it's again a complex number. So it satisfies the closeness property. So complex number is post under multiplication and complex number is commutative and it also satisfies the commutative law and it also satisfies the associative law. That means if I take any three complex number, if I take any three complex number Z1, Z2, Z3, then this equal to Z1 multiplied with Z2 multiplied with Z3, this equal with Z1 multiplied with Z2 multiplied with Z3. And here also exists a multiplicative identity, multiplicative identity. That is, there exists one complex number. One can be written as 1 plus 0 into I. So if I multiply it with any complex number, suppose Z is my complex number, and I multiply it with 1 plus 0 I. So what I will get? I will get again Z. So 1 is my multiplicative identity of complex number. And there exists an inverse also. Existence of multiplicative inverse. Well, you know that for any real number A, there exists another real number 1 by A. 1 by A such that A multiplied with 1 by A, it gives 1. In complex number also, this property satisfies. For example, if I take any complex number Z, there exists another complex number 1 by Z such that Z multiplied with 1 by Z equal to 1. So how to find 1 by Z? So if I take a complex number Z, A plus IV, then what is the inverse of Z? It, that means what is 1 by Z? We have to find 1 by Z. So 1 by Z is what? 1 by Z is 1 divided by A plus IV. This can be written as, if I multiply it with numerator and denominator with A minus IV, what I will get? 1 divided by A plus IV multiplied with A minus IV and divided by A minus IV. So this equal to A minus IV divided by A square minus IV square. So this equal to A minus IV divided by A square, and here IV square, this equal to what? I square and B square, and we know that I square equal to minus 1. So minus 1 multiplied with B square, this gives minus B square. So this equal to what? Minus B square. So minus and minus B square, minus and minus B square, and this is equal to A minus IV divided by A square, and minus minus plus, so plus B square, and this can be written as A divided by A square plus B square plus I minus B divided by A square plus B square. So for any complex number Z equal to A plus IV, where we have a complex number A divided by A square plus B square plus I minus B divided by A square plus B square. So if Z is A plus IV, then 1 by Z is 1 by Z, or Z inverse is what? Z inverse is A divided by A square plus B square plus I minus B divided by A square plus B square. Okay. So for example, if I take one a complex number Z is 2 plus 3I, then find the inverse of Z. That means 1 by Z, or Z inverse. This equal to what? This equal to A divided by 2 divided by 2 square plus B is what? B is 3. So 3 square and plus I. Here this here minus B. So B is 3. So minus 3 divided by A square plus B square means 2 square plus 3 square. And this equal to what? This equal to 2 divided by 4 plus 9. So 13. 2 divided by 13, and plus minus a minus. Or we can write in this way also, I minus 3 divided by 13. So for the complex number 2 plus 3i, the inverse is what? 2 divided by 13 and plus I minus 3 by 13. And the complex number satisfies the distributive property. Distributive property. That is, if Z1 and Z2 and Z3 are three complex number, Z1, Z2 and Z3 are three complex number, it satisfies the distributive property. That means Z1 multiplied with Z2 plus Z3, this is equal to Z1 multiplied with Z2 plus Z1 multiplied with Z3, and Z2 plus Z3 multiplied with Z1 equal to Z2 multiplied with Z1 plus Z3 multiplied with Z1. So complex number satisfies the distributive property. Next, I will discuss division of two complex number. Division of two complex number. Division of two complex number. So given any two complex number, given any two complex number, given any two complex number, any two, sorry, any two complex number, complex number Z1 and Z2, Z1 and Z2, where Z1 not equal to 0, where Z2 not equal to 0, the quotient, the Z1 divided by Z2 is defined by defined by Z1 multiplied with 1 divided by Z2. So for example, if I take two complex number, for example, if I take two complex number, let Z1 equal to 6 plus 3i and Z2 equal to 2 minus r. Now we have to find the division of two complex number, that is Z1 divided by Z2. So here given that Z1 is 6 plus 3i, so 6 plus 3i and Z2 is what? 2 minus r. Next, this can be written as what? 6 plus 3i multiplied with 1 divided by 2 minus I, and this equal to 6 plus 3i. And now if I multiply numerator and denominator with 2 plus I, what I will get? 1 multiplied with 2 plus I, 2 minus I multiplied with 2 minus 2 plus I. So this equal to 6 plus 3i multiplied with 2 plus I and divided by, now we know that a minus b and a plus b, this equal to what? A square minus b square. So this equal to 6 plus 3i multiplied with 2 plus I, and all that I square minus 1, so 2 square 4 and I square minus 1, so plus 1, minus minus a plus, so plus 1, and it's equal to what? 1 divided by 5, 6 plus 3i multiplied with 2 plus I. And this equal to what? This equal to 1 by 5. And here A plus IB and C plus ID. The product of two complex number. This equal to what? A multiplied with D. Here you directly use the formula, or we can use the distributive property also. So if I use the direct formula, so A multiplied with C, here A is 6 multiplied with C is 2 minus D multiplied with 2, D. So B is 3 and D is what? D is 1 plus I and A multiplied with D. So here A is 6 and D is what? D is 1 plus B multiplied with C. So B is 3 and C is 2. So this equal to what? 1 by 5 and this equal to 12 minus 3, 9 plus I, here 6 plus 6, so 12. So 9 plus 12 I. So if Z1, Z2, any two complex number, we can find in this way the division Z1 divided by Z2. Now I discuss power of I. Now I discuss power of I. Power of I. So we will define that I equal to square root of minus 1. And if I square both sides, then I will get I square equal to minus 1. Now I cube can be written as what? I cube. It can be written as I square multiplied with I. Well, you know this property that a to the power x multiplied with a to the power y. This equal to what? A to the power x plus y. So I cube can be written as I square multiplied with I. And here I square equal to what? I square equal to minus 1. So this equal to minus 1 multiplied with I. Now minus 1 multiplied with I, it gives minus I. Next, if I to the power 4. I to the power 4 is what? I to the power 4 is I square multiplied with I square. And I square equal to what? I square equal to minus 1 multiplied with minus 1. Now minus 1 multiplied with minus 1, it gives plus 1. So I to the power 4 is plus 1. Next, I to the power 5. I to the power 5 is what? I to the power 5 is I to the power 4. It can be written as I to the power 4 multiplied with I. We know that I to the power 4 is what? I to the power 4 is 1 multiplied with I. So it gives I. Next, I to the power 6. So I to the power 6 is what? I to the power 5 multiplied with I. And we know that I to the power 5 is what? I and multiplied with I. So this equal to I square. And we know that I square equal to minus 1. Or this can be written as I square multiplied with square. So I to the power 4 multiplied with I square. So this equal to what? I square equal to minus 1 third square and I square equal to minus 1. So minus 1 is equal to 1 and minus 1 and it gives minus 1. So I to the power 6 is minus 1. Sorry. So in general, this can be written as okay. Okay, if the power is negative, then what happens? If the power is negative, suppose I to the power minus 1. This is equal to what? I to the power 1 on. So Here I discuss j to the power minus n we can write as 1 by j. So I to the power minus 1 it can be written as 1 divided by I. Now if I multiply I with numerator and denominator, what I'll get? I divided by I square. Now I square is what? I square is minus 1. So I divided by minus 1. And this is equal to what? This is equal to minus I. So I to the power minus 1 is equal to minus I. And I to the power minus 2. This means 1 by I square. So this is equal to what? 1 divided by minus 1 and it gives minus 1. And I to the power minus 3. This is equal to what? I to the minus 3 1 by I cube. And this can be written as 1 by I square multiplied with I. And already know that I square is what? Minus 1 multiplied with I. So minus 1 by I. And we know that if I again we multiplied with plus I with numerator and denominator, what I'll get? This I'll get minus I divided by I square. And I square is what? Minus 1. So minus I divided by minus 1. And this equal to I. So if I take any power, I will get plus 1 or minus 1 and I and minus I. This for will. Only this for will. So so in general, for any integer k, for any integer k, any integer k, I to the power 4k is what? I to the power 4k is 1. I to the power 4k plus 1, it gives I to the power 4k plus 2, it gives minus 1. And I to the power 4k plus 3, 4k plus 3, it gives minus I. Next I will discuss modulus and conjugate of complex number. Modulus and conjugate of complex number. So the modulus and conjugate of complex number. So let j equal to a plus iv. Let j equal to a plus iv be a complex number. Be a complex number. Complex number. Then the modulus of j. Then the modulus of j. Modulus of j denoted by denoted by denoted by mod j and is defined to be non-negative real number and is defined to be non-negative non-negative real number. It is modulus of z, that is modulus of z equal to square root of a square plus b square. A square plus b square. Next we will see that the modulus of z is nothing but the distance from origin to the point. Origin to the point. Okay. Next is conjugate. And the conjugate of z and the conjugate of z conjugate of z denoted as denoted as z bar is the complex number is the complex number a minus I a minus I. So z bar is what? Z bar is a minus I. Only we replace I with minus I. For example, if I give a complex number, if I give a complex number, suppose I will give a complex number. For example, if I take a complex number, z is 2 plus 3i. Then what is the modulus of z? Modulus of z is nothing but that is what? That is a square. Here a is what? 2. So 2 is square. And here a is b is what? 3. So 3 is square. This is equal to what? 2 square plus 3 square. And this equal to, sorry, again I write the same line. So 2 square is 4 and 3 square is 9. So this equal to what? This equal to square root of 13. And what is the conjugate of z? If z equal to 2 plus 3i, then conjugate of z denoted by z bar. And it's equal to what? Only we replace I with minus I. So 2 minus 3i. 2 minus 3i. 2 minus 3i. Okay. Okay. So now I'll discuss some properties of complex number. It is earlier we see that z inverse equal to 1 by z, right? Z inverse equal to 1 by z. And it's equal to what? 1 by z is equal to a divided by a square plus b square and plus I minus b divided by a square plus b square. So this equal to what? Here the denominator are same. So we add the numerator a minus I divided by a square plus b square. Sorry. Now a minus iv. This equal to what? This equal to conjugate of z bar and a square b square. This equal to what? Modulus of z square, because modulus of z is equal to square root of a square plus b square. Now if I take square both sides, then this equal to modulus of z square equal to a square plus b square. So here we will get that z inverse or 1 by z equal to z bar divided by modulus of z square. So what do we get? That is z bar square equal to z multiplied with z bar. Sorry, z bar. Z bar. Okay. Furthermore, the following result can be right. The first result is z1 multiplied with z2. This equal to z1 z2. It is modulus of z1 z2. This equal to modulus of z1 multiplied with modulus of z2. And next result is modulus of z1 divided by z2. This equal to modulus of z1 divided by modulus of z2. And the third result is z1 z2 modulus of z1 multiplication z2. This equal to, sorry, conjugate of z1 z2 is conjugate of z1 and multiplied with conjugate of z2. And the fourth is conjugate of z1 plus minus z2. This equal to what? Z1 conjugate plus minus Z2 conjugate. Okay. And another one, fifth result is if Z1 divided by Z2 and conjugate of these two, this equal to what? Conjugate of Z1 divided by conjugate of Z2. Now, we solve one example, that is find the multiplicative inverse of 2 minus 3i. Find the find the multiplicative inverse 2 minus 3i. We can find directly the multiplicative inverse of 2 minus 3i by using the formula that a divided by a square plus b square plus minus b divided by a square plus b square. But here we use the formula for understanding this formula, that is z inverse is z conjugate divided by modulus of z square. So here we use the formula. So Z bar is what? Z bar is 2. We replace I with minus I. So this equal to 2 plus 3R. And modulus of Z is what? Modulus of Z is square root of A square and plus B square. So here B is minus 3. So minus 3 square. And this equal to square root of 30. So Z inverse is what? Z inverse is Z bar, Z bar means conjugate of Z divided by modulus of Z whole square. So here conjugate is 2 plus 3i divided by square root of 3 square. This equal to 2 plus 3i divided by 13. So this equal to 2 divided by 13 plus 3 divided by 13i. So if the complex number z is 2 minus 3i, then the conjugate is 2 divided by 13 and 3 divided by 30i. Okay. Okay. We solve one more example, that is express the following in the form of a plus I. Express the following in the in the form a plus ib. Here given that z is 5 plus square root of 2i divided by 1 minus square root of 2i. So this can be written as 5 plus square root of 2i and okay. So this can be written as 5 plus square root of 2i divided by 1 minus square root of 2i. Now if I multiply it with the conjugate of this one, so this can be written as square root of 2i multiplied with, so conjugate of this is 1 plus square root of 2i. So I multiplied and divided with conjugate of 1 minus square root of 2i. So 1 plus square root of 2i. Now this is equal to what? 5 plus square root of 2i multiplied with 1 plus square root of 2i and divided by a minus b and a plus b. So here we use the formula a square minus b square. So a square and b is what? B is square root of 2i square. And this equal to what? This equal to 5 plus square root of 2i and multiply it with 1 plus square root of 2y divided by 1 square minus square root of 2y third square. So this equal to what? 1, and we know that I square equal to minus 1. So this equal to plus square root of 2 third square, this equal to 2. So plus 2. So this equal to 1 by 3 multiplied with, now this one complex number and this one another complex number. So multiplication of two complex number. Multiplication of two complex number is what? Here a multiplied with c minus b multiplied with d. So here a is what? A is 5. So a multiplied with c. So 5 multiplied with 1. C is 1 and A is 5. So A multiplied with C minus B multiplied with D. So square root of T is square root of 2 and D is square root of 2 plus I and what? AD multiplied AD plus BC. So A is 5 and D is square root of 2 plus BC. So B is what? B is square root of 2 and C is 1. So this equal to 1 by 3 and here 5 square root of 2 multiplied by square, this gives 2. So 5 minus 2, so this equal to 3, and here 5 square root of 2 plus square root of 2, so 6 plus I 6 square root of 2. And if I take divided by 3, then this gives 3 divided by 3, so 1, and 6 divided by 3 is equal to 2. So I 2 square root of 2. Understood? Now this in the from a plus iv, here a is 1, here a is 1 and b is what? B is 2 root 2, 2 root, and this is in the from a plus I b. Lastly, I discussed Argand plane and polar representation. So the complex number Argand plane and polar representation and polar representation. So the complex number x plus iy which correspond the ordered pair. So for complex number x plus iy, this corresponds the ordered pair x comma y, x comma y can be represented geometrically as the unique point pxy in the xy plane and vice versa. So if I take some complex number, suppose 2 plus 3i, 5 plus 2i, and 6 plus 7i, and so on. So this 2 plus 3i, this can be written as 2 comma 3, and 5 plus 2i, this can be written as 5 comma 2, and 6 plus 7i, this can be written as 6 comma 7. Okay, so all you know Cartesian Cartesian plane. So if I draw a Cartesian plane like this is x-axis and this is y-axis. So this is x dash and this is y dash. X the x is called the real axis and y is called imaginary axis. Suppose this is 1, 2, 3, 3, 4, 5, 6, 7, 8, and so on. So 1, 2, 3, 4, 5, 6, 7, 8. So and the first number is what? First number is 2 comma 3. So here x axis 2 and y axis 3. So the first point is here. First point is here. So here 2 comma 3. 2 comma 3. This is the representation of the complex number 2 plus 3i. 2 plus 3i. And the second number is 5 comma 2. So 1, 2, 3, 4, 5 and 2. So 5 comma 2 here. So this is the complex number 5 comma 2 and 5 plus 2i. In this way, we can represent any complex number in the Argand plane. In the Argand plane. So the plane having a complex number assigned to each its point is called the complex plane and Argand plane. So here in the complex plane, we assigned of each point is complex number. Here 5 comma 2 it's equal to what? 5 comma 2 means 5 plus 2i. We assign a complex number in each point. So this plane is Argand plane or complex plane. Okay. So when I discuss modulus, what I said, the modulus of z is nothing but the distance from the origin. Okay. Suppose this point, this point. So 2 plus 2 comma 3. That is this equal to what? 2 plus 3i, a complex number. So this distance is what? If I find the distance from the origin, this is what? Square root of 2 minus 0 that was square and 3 minus 0 that is square, that is 3 square. So this equal to what? This equal to nothing but modulus of z. And what? Argument of z. Here 2 plus 3i. And what is the argument of 2 plus 3i? If 2 plus 3i, if z equal to 2 plus 3i, then argument of z is what? 2 minus 3i. So 2 minus 3i. X is 2. 1, 2, 3, 4, 5. So x is 2 and y is minus 3. So this point approximately here. Approximately here. Approximately here. So if I connect by a line, so this equal to what? This equal to 2 minus 2 comma minus 3. This equal to 2 minus 3i. So argument of z is the mirror image of x axis. See, so here 2 plus 3i and mirror image. So this is if I connect this one and okay. So if I connect these two, you see this is the mirror image of this point, and if I assume that x is mirror, so 2 comma 3, the image is here 2 minus 3. Understood? So modulus of z is nothing but the distance from the origin, and argument of z is the mirror image. Okay, thank you.